So hello and welcome again, students. Today we shall continue with part 2 of your chapter 3, language of chemistry. In our last class we learned how to differentiate between symbols and formula, elements and compounds when they are represented on the two-dimensional page like this. If you see something like HCl is written, now you know that this HCl is a formula, right? And it represents what? It represents a molecule of a compound. Just like H2, it represents what? Molecule of a what? Element. And if I simply write H or if I simply write Cl, these represent simply atoms of hydrogen and chlorine, whereas this represents molecules, molecule of hydrogen and molecule of hydrogen chloride. Okay, since it is made up of two different types of atoms, it's a compound, right? And it's an element because both the atoms are of the same type. That's what we discussed in the previous class. But now let us a little bit elaborate on this. Whenever we are writing the names of the elements or compounds, whenever we are trying to write the name from the formula, we need to remember certain things. First of all, as I have already told you, when I am writing HCl, we'll write hydrogen chloride. We do not write hydrogen chlorine. On their own, H simply means hydrogen. Cl simply means chlorine. Cl simply means chlorine, right? We know that from lower classes. This is hydrogen and this is chlorine. But when we write them together, we will not write hydrogen chlorine. We'll write hydrogen chloride. The second one, the ending changes to a IDE. It's a common pattern. It's not always true, but you will find in many cases this is to be the system. Okay, for example, if I write that we started, remember, in the first class with this no, which does not mean no. We started with N and O. This is N and O combination, right? So N is nitrogen, O is oxygen. We don't write nitrogen oxygen, we write nitrogen, and the oxygen turns into an oxide. Just like here it turns into chloride. So it will be something like this. However, there is a problem with this kind of naming. There is a problem because we have compounds like this also. Then we have compounds like this also. How will we name them, right? Because both are, it is also a combination of nitrogen and oxygen. It is also a combination of nitrogen and oxygen. Now how will we write the names? There is a system where you can just see the number of oxygen here, or in this case you can see the number of nitrogen here, whichever is different here. First of all, if you see here nitrogen, oxygen, only one. Here nitrogen, oxygen, there are two oxygens here, right? So we can, for one oxygen we can write monoxide, okay, monoxide. And for the second one we can write in a similar fashion nitrogen, but here since there are two oxygens, so we can write dioxide. Again di because there is two, and always the ending changes, okay? It was simply oxygen, but in the compound we are naming it as oxide, okay? Again you can see here nitrogen is here, again oxygen, but here nitrogen is 2. Okay, so we can write it in this manner also, dinitrogen monoxide. Dinitrogen monoxide. However, these also have common names. Okay, there is a rule, there is a pattern here, but if I use the other common names, there is no pattern. For example, NO can also be called nitric oxide. Okay, still there is a pattern actually, but we'll come to that later. Nitric oxide, and it will be still nitrogen dioxide, and this one may also be known as nitrous oxide. Nitrous oxide. Now those names are also not without any meaning. They also have a pattern. But we'll talk about that pattern later on. First, you remember this pattern. Okay, this pattern. When we are using the number of the elements, okay, the atoms, okay. For example, element oxygen, there are 2 atoms of oxygen here. So it became dioxide. Okay. Here 2 atoms of nitrogen, so dinitrogen. Since 1 atom of oxygen, it becomes monooxide instead of like di here. Okay, so let's just focus on this type of ruling, on this type of rules maybe for some time. Let's take some other example here. For example, SO2. Now if you follow the previous pattern, S means what? Sulfur. So we'll write sulfur, and O means oxygen, but as we have seen, we are not writing oxygen, we'll write oxide, right? So we'll write oxide. But there is 2 oxygens, right? There are 2 oxygens, so we'll write dioxide. Simple enough. If it is SO3, now what shall we do? The number is higher. Mono means 1, di means 2, tri means 3. So simple enough. So in the same pattern we'll write sulfur, trioxide. So these kind of names now you can figure out, right? Just by seeing if there are like 2 compounds of between the same 2 elements, however the number of atoms combining are different. So according to that you can give different names. Let's see some other examples. CCl4. Okay, so before we get to this, you must be wondering already, 1 means mono in this kind of nomenclature, 2 means di, 3 means tri, 4 means tetra, 5 means penta, 6 means hexa, and so on. You remember till 6 now, okay? Remember till 6. So following that pattern, we can easily solve this one. C stands for what? You've studied already. Carbon, right? So carbon. And Cl stands for what? Chlorine, right? But in a compound, we're not going to write chlorine, we're going to write chloride. And 4 means what? Tetra. So simple enough. Carbon, tetra, chloride. So you can do, having this information and knowing how to use them and piece this together, you can do other examples. So I'll give you a little bit of a task today. Okay, if you want to do, you can do along. And if you have problems, you can contact as usual. You have the WhatsApp number of the teachers, no problem there. So let me give you some task, simple enough, very simple, which you can do by whatever you've learned here right now. So you try to name this, okay, name the following compounds. Name the following, okay? Or we should write like this, give the chemical names, okay? Give the chemical names of the following. So I'm giving some compounds here. You'll give the names. First one is PCl3. Second one is PCl5. Then very common one which you already know, CO2. Then CO and P2O5. You try these 5. I think you can do this in the same way. First one, as you have seen, there we have to take the name of both the elements. The ending is modified to an IDE, and the number, how many chlorines are there or how many oxygens are there, we add to that, right? In the middle actually we add before the ending. So we have seen all this. We have seen a few examples. Let me show one last example. Say one last example. Carbon dioxide, so I have given you. Let me show you carbon disulfide. Okay, this one. See, C means what? Carbon, you know already, and S is sulfur, right? So you just have to use, it's 2 here, so you have to add di, and to the ending you always modify to be IDE, right? So what will this one be? Carbon sulfide, because S is at the ending. Add will just di. So in this pattern you can name a lot of compounds. Okay, in this pattern you can name a lot of compounds. If you know the names of the elements, if you see the first element, you write it as it is. The second one you just modify it to IDE and then add the number, whatever number is there. This is one pattern. You can try to solve these things in a similar way. But all elements or all compounds cannot be named in this format. You have to know something called the Valency chart, which I believe you have had even in class 7 to some extent. But here you have to a greater extent here, more things to memorize basically. The Valency chart you must learn.